Hey guys, welcome back to another video. This is course schedule 2 and I'm gonna actually be live coding this. As you can see, no submissions yet. So let's see if I can actually do it or not. So the basic problem says that there are some prerequisites to a course that you need to take, and if you cannot take those courses, then, well, what do you return? Well, I don't know, but uh, you return an empty array. Okay, here we go. Anyways, so I've done course schedule 1. So basically prerequisites. So I need to create a graph and I can do a DFS. And all I need to do is also output in the order I should be printing them. So this seems like topological sort. So basically if I just do DFS, put them in stack and then pop out of stack and print it, that would be topological sort. Topological sort is basically nothing but reverse DFS. So since we know that, let's create a graph list. And so basically I'm saying an array of list, and then I'm saying a graph to new list, and then I'm gonna initialize this graph with the number of courses, and then I'm gonna say graph I equal to new list, and right. Now I wanna populate the graph as well. So for int I equal to 0, I is less than, so I want to populate the graph in the sense that if I have 1, then 1 depends on 0, and 1 doesn't depend on anything. 3 depends on 1, 3 depends on 2. I believe that's what they want, right? That you must take the course BI first. Okay, so it's basically kind of like a dependency graph thing. So I need to go to the length of prerequisites here. Prerequisites dot length I plus plus. Then I need to say graph prerequisites I 0 dot add prerequisites I1. Basically, I'm saying 3 depends on 1, 3 depends on 2, 1 depends on 0, 2 depends on 0, 0 doesn't depend on anything, it's an empty array. Okay, that makes sense. Okay, we have a graph made, we put all our dependencies in a, okay, perfect. Now, I would like to do a DFS. So let me create a visitor so that we do not visit the same thing again and again. We can also create it as a single array, not even a bool, because if there's something in, we want to avoid cycles, so we want to do like int visitor equal to new int, and then I'm just going to say num courses because that's the max amount of 0 to n minus 1 we can go. Then I'm going to do in I 0, I is less than equal to prerequisites, or should I do num courses? I can kind of do num courses. I plus plus, and then I want to do some kind of DFS here. So let's see, what should I DFS return? I also want to create a stack of n, because it's just a reverse DFS for topological stuff. So one thing I want to pass in is a stack. Another thing that can be useful is to pass an I. Then I just want to do a DFS of an int I, stack, int, stack. And then I want to check few stuff. So basically I just want to go to the neighbors of it. So I just want to say for int j equal to 0, j is less than. Okay, also need to pass in the graph so that we have graph reference to. graph. So, oh, so say I passed in 0. So I dot count j plus plus. So basically 3 has 2, so it can iterate 2 times. I should be able to set this to DFS again here, but if I say if, I need to pass in the visited as well. Say visited. If visited I is equal 1, then let's do a bool, say return false, because there's a cycle, this can never be completed. If DFS and then equal false, basically we found a cycle. Once we found a cycle, all I'm gonna say is I just wanna return an empty array. So new int and a size of what? It's an empty. So I guess 1 would do it, 0 wouldn't make sense. So new int 1. Apart from that, we have it in our stack anyway. So all I'm gonna do is put this in my list, res equal to new list and stack. Now I don't know if there's a method that does this exist inside C# or not, but I'm hoping there is, where it automatically takes a stack, converts in a list, and then I can do return res dot to list. Anyways, once this is done, I'm gonna say visited I equal to 1. Then inside here, I'm gonna do DFS. And inside the DFS, I'm gonna say I just want to pass in my element. So the element which I am gonna be passing in is actually gonna be graph I comma j. So basically 3, now pass in 1. That makes sense. Element stack comma graph comma visited. Once we are actually done visiting fully, visiting I equal to 2, stack dot push. Uh, hmm, I just wanted to reverse DFS. Do we push it here or do we push it later? Okay, we push it here. So that means when 3, 1, 3 to 2, it would push in 2. Topological sorting means that a vertex V cannot appear before U, I believe. That makes sense. That makes sense. Return through here. And then you're gonna say that if this element is not really visited, then do this. Because if it is already 1, doesn't make sense. If it's already 2, you don't need to do it. That's perfectly valid. If it's 1, just return false. And if it's 0, then you do it. Okay, makes sense. Element, element. So working on a paper, I'm gonna see for the first one, I'm gonna pass in a 0. 0 is gonna be set as 1. 0 has no neighbors. 0 is fully visited. Stack.push 0. Return true. Then I'm gonna pass in 1. 1 is gonna set to 1, like it's been process of getting visited. It has a neighbor 0. 0 is gonna go in. It's gonna say it's getting visited. I can also say that if visited I is equal to true, then just return me true. Oh wait, but yeah, but that probably wouldn't even happen because I already have an if condition saying that if it's 0, then only do it. So 0 will probably never even enter. So 1 is also going to be good. Then we're going to go to 2. 2 again, going to go to 0. 0, it's going to say good. 3 is going to go to 1. 1 is um good. 3 is also going to go to 2. It's also good. Um, I'm going to run the code. Array creation must have non-courses, cannot implicitly convert from to in. At line 21, cannot implicitly dot to array cannot implicitly convert from into bool 32. Expected should be 0. 0 is not actually on the top. Huh. That actually makes sense. Because wait, topological sorting. Just do me a favor on all these further. Returning it in a reverse order. Is there any way I can fix it? Let me search. What is topological sort? Just so that I can get an idea. Such that every directed versus UV vertex hue comes before V in the ordering. Yes, that's what I said. Uh, yeah, so yeah, makes sense. Hmm. Wait, that makes so much sense that you're okay. Wait, so I put in a 0, but 0 comes in the stack before, and then 1 comes in the stack before. So that 1 gets put here, and then 0 gets put here. I think I understand why this is probably not working because their constructor method is different. I can do that on my own. And we just say I can put it into the list in the same way, but basically we just need to start from the end and then go to the front. I can directly even create an array for this. Yep, that would make more sense. And by the way, we could also like reverse our solution. That would work, but I just don't want to do that. It's like a little bit more trying to get more efficiency. index equal to num courses minus 1 index minus minus equal to v res. Okay, now I just want to test my solution. Oh, they already tested for me. Okay, okay. Let's see if it works. It works. Uh, I just want to see how many test cases did I pass. I only passed 13. So I'm saying 2, 0 depends on 1. So 0 depends on 1. So first 1 goes in, 1 gets in the stack. Then 0 goes in, 0 goes in the stack. In my res, 0 comes here, 1 comes here. Makes sense. Where did I mess up? Where did I mess up really? Because it makes sense with what we have. Currently it makes sense. Because what I'm saying is first 0 will go in, 0 is gonna be like, okay, set me to 1. Then it's gonna be like I have one neighbor 1. Go take me to that neighbor, do me a DFS. Neighbor gonna set to 1, doesn't have any neighbor, 1 is gonna be set, put in a stack. So our stack actually looks like 1. Then it's gonna get returned. Then it doesn't have any more children. So it's gonna get pushed here. Then stack it's gonna return me true. Then I am actually gonna go to 1 due to my for loop. And then the for loop is gonna say, okay, 1, I'm in the 1, but 1 has literally nothing, no children. I kind of want to have this loop too. So 1 has no children basically. So but 1 is already set to here, so it's just gonna return me true. And then once it returns me true, I'm just gonna go here. I'm gonna say in the last index of res, which is gonna be 2 minus 1, it should be 0 here and 1 here. Doesn't make sense. Why not? Let's see, check something. Right line, which is 2, of course. True. Oh, this is true. Let's run this code hopefully. Okay, that never executed, which is strange. And the reason for that being strange is we first did 0. 0 should do everything in its power to make this a 2. Unless, okay, there's a suspicion I have. Oh, I just. Oh, hmm, very cool. Just want to see at this point console dot write line visited 0 console dot write line visited 1. What are they? Both are visited, which is correct. I start with a 0, correct. I say go to 1, courtesy of this. 1 also gets set to 1 from this line. 1 doesn't have any neighbors. It gets set to 2. It gets pushed into the stack right here, and then it returns true. It returns true. Then we get to 0. 0 is gonna say, okay, done. Then it's gonna say, okay, I'm gonna also get set to 2. I'm gonna also gonna get to pushed in the stack, and I'm gonna return true. So my stack should look like this. So my index is actually the last one, so I'm just gonna say in my stack, I just wanna have my topmost element. The other cases are passing this one is points. This is this is this is so strange. I don't have a good explanation for this, to be honest. The only last thing I know how to solve this question is open the Visual Studio, really. That's like my go-to thing when I really cannot figure it out. We're gonna say course schedule 2, hit create. We only had like a one row, and then prerequisite 0 equal to new, and we had 0 comma 1. I'm just gonna pass in prerequisites here. I'm gonna do potential fix. Call this one static 2. Using system, and then do this. Then go inside. I hope my audio is getting recorded. Would suck if it's not, really. Is it? How do I check? I think so. Seems like it. First, I create this. My graph basically has 0 has 1, 1 has nothing. Pretty straightforward thing. I put breakpoint over here. Ah, I see. How was it even working? Damn. Oh, I see. Like it's just gonna be graph. Same thing. I comma j here. Not even. Let's see. Oh, but gosh. Console. Let me just go to the res. Hit res. And cool. Very cool, sir. Very cool. Run code. So run code. Thank you. Submit. I'm surprised with this because we're saying 0 goes to 1. Both of them now are marked as being visited in the process. One says, I have an element. Oh, you don't need this condition here. Let's run the code now. Huh? Okay. I mean, let's put that back in and let's say that if visited, just gonna this out this point, element equal 1, just return false. Because right now what's gonna happen is it's gonna go to 0, it's gonna go to 1, then it's gonna come out 1, 1 will say I have a neighbor, but it's not set to 0, so I can do nothing if I take out that 0 condition too. It's gonna go in again. It's gonna go to 0, it's gonna say it is already set to 1, return me false. This will return false. And then 0 is gonna be like, okay, that should return me false too. Hmm. Huh. You need it empty. God damn it. Say I just want to try something new too. Say, no, not this. God. I want to remove this. I just want to see something else. Hmm. For better understanding, I'm definitely gonna go in with this one. I'm gonna try and see in my understanding. It continue, and I'm also gonna remove this statement. Rerun it, continue, returns false. Cool, that should do it. Return false. That should do it. And then finally, I am gonna have an empty array there. There many return if it is impossible. What happens if you return zero? Can you? I mean, I'm gonna try. Say, my Python kicked in. Num course is equal to 1. Return unit 1. No, you can do that. Nice. Then we have that. Some thank you. All right. So I hope you guys understood it. If you watched it, that's typically, I think, what I did right now. Showed some of lacking behavior, but it also showed like a good problem solving behavior in an interview, like lacking behavior in the sense like I could be more cognizant of stuff like me making small mistakes like these things. I had the correct logic from the start. That was not the issue. But what I displayed is good like behavior of solving skill, having like a sense way to detect them. Yes, at some places I didn't need to use like a debugger, but that's also perfectly fine in real world use case scenario. So overall, was a positive interview. I showed my thought process and what I'm thinking. That's really important in an interview. So hope you guys learned something from it. And kind of just want to talk time complexity here. You're saying just visit everything just once. So that's just O of n. You're saying do a DFS for everything, but I believe it's still O of n because if it's already visited, you don't want to visit it again. So pretty much that's it. O of n. This is again O of n. Perfect. For space complexity, stack O of n, creating an int of this um is gonna be n into n. So I guess base complexity wise, it's n into m, I believe. Yep, seems like it. Correct me if I'm wrong, guys. I kind of mess it up. But time complexity, I do think it's an O of n, but I could be so wrong because it's only faster than 25% solution, but it's for fun. 72%, that's great. I'm saying O of n, I should not be saying O of n, I should be saying O of n into m. Because it's a this, so m, where n is the row length and m is always kind of constant. Okay, let me rephrase it. O of n for the time complexity, and space complexity is again going to be um O of because you can have it this and you can have it. So space complexity can be O of n squared because everything can be connected in a like a cycle, huge cycle. Everything can be connected in a huge cycle. Does that change time complexity? Well, you do visit every element once. And because if you're kind of visiting it again, it's just gonna be visiting it again. Would it? Would it? I just wanna see. Let's see if it has a solution that's very, very cool, sir. Time complexity, time complexity. Yeah, I wasn't wrong about it. V plus E. That's the general one. So I can kind of say that. Because this can never be like n squared, so that's all right. All of n should be an acceptable answer, I guess. V plus E, that's where I was wrong. Maybe they're using something else. Uh, yeah. They're doing it. Oh, they're doing the colorway. Okay. Seems like their solution's more complicated. It is what it is. In degree, I like this in degree way too. I learned it back then, but never really use it. I always use uh, the solution which I have. Reverse DFS. So easy to remember, just reverse the DFS. But this might be good too. Alright, guys, that's about it.